is Laura, and I'm here to tell you about Programmable Minecraft, which is a project we have at the Universidad Abierta Interamericana Dedicated Research Group. We work mainly with educational robotics, but we work with anything educational. So Programmable Minecraft is a project that we want to use to teach people computer science using things they already know. So first, I'd like to talk to you about Minecraft. Who here knows what Minecraft is? It's a good proportion, but anyway, I'm going to show you a quick demo of what Minecraft is. So here's Minecraft. I will open the world here. And as you can see, I don't know where I got here, graphics are pretty peculiar. Everything is made out of blocks. And there are basically three things you can do in this game. You can mine blocks. So you get something when you mine them. In this case, I'm getting the same kind of block of mining, but I could get anything. You can put them back. And you can use these blocks to craft different items. For example, if I get a wood block here, I can open my inventory, put this wood block in this little crafting table, and make wood planks. So these are the only three mechanics this game has. And this makes it a very special game because it really gives a lot of freedom to the players. There are no preset rules, no preset roles, goals. It's like a huge virtual Lego. You can do whatever you want, and you're only fueled by your own imagination. So this really is a very special game. And it also is very popular among kids and other people. So it's very useful to use as a metaphor because people already know what you're talking about. And then I'd like to talk about teaching computer science. Why should we teach computer science in schools? There are many reasons for this. There are lots of different arguments from different points of view. People will tell you about how we need a workforce and there are lots of jobs available and not enough people to fulfill those jobs. But I have a different argument, which is just as valid, and it is because computer science, like any other discipline, has its own models, and the more models you know, the more tools you have to solve any problem you encounter in your daily life. Computer science as a discipline is useful to train different abilities, such as logical thinking, subdivision of problems. So basically, the more you know, the more prepared you are for different tasks you might encounter in your life. And we have many tools to teach computer science. There is lots of material on the internet. We can find books that are dedicated to the desk with lots of educative material and talking about pedagogical devices. And there are also some environments that are useful for teaching computer science concepts, such as Scratch or eToys or Alice 3D. Particularly, I chose three environments that are related to the object-oriented paradigm, but I chose three. So, So what about Minecraft? How can we use Minecraft to teach computer science? In the lab, we thought Minecraft had the special characteristics I mentioned before that were particularly useful for teaching computer science, in the sense that we can use what people already know by playing Minecraft to get them closer to the object-oriented paradigm. And we thought Smalltalk would be a great companion with Minecraft to teach computer science. So what we did was modeling Minecraft from the object-oriented point of view, build this model on Squeak, and modify Minecraft so we can use this model we built on Squeak to dynamically modify the behavior of the objects that we can find in Minecraft. So on the modeling part, what we did was grab the different things you can recognize in Minecraft, such as blocks, entities which are monsters, sheep, cows, different mean monsters such as creepers or zombies that attack you, and assign them particular behaviors. So, for example, you can place blocks, you can mine them, you can ask the Minecraft world what block is its specific position. So, here's a quick demonstration of what we did. Of course, this might blow up in my face because it's a really early version, but I'd like to show you what we're working in. So here's Squeak. I have a Minecraft object which is currently connected to the game through sockets. This is not a planned architecture, but it is what we're working on with now. And I will run Minecraft from the development version. And just for the sake of demonstrating, I will open a plain world, which is like any other Minecraft world, but it is completely plain. So I have this little item here that sets a variable, that it's a word variable. It's useful for interacting right now. And I will check some stats. For example, now I am standing at that position you see in the screen. And for example, I can place a block. So if I talk to the game, I talk to its world, and I tell that at the position I'm standing, let's make this smaller so we can look at both things at the same time. And I execute this. Whoops. I typed wrong. So the socket died. That's why we do not plan to use sockets. So let's quickly reboot the socket. Set the world, and there it is. Now, this is a very simple demonstration, but what we are talking about is that with this simple command, you can place a block. And since we are on Smalltalk, we can use any other of Smalltalk's features. So if, let's say, I just grab some blocks here, and I place them manually, and it takes me some time. Let's say I want to build a complex structure in Minecraft, and it will take me a lot of time, and I had to think where I'd place blocks and go one by one, and I might miss some place. But using programming, I can make very complex structures in Minecraft at a blink of an eye, and only thinking about code and don't having to do repetitive actions. So there really is a motivation for people using this to learn programming using a very popular game. For example, let's say I want to build a wall. So say 1 to 10. Oops. I surround it in another loop. So I go horizontally and vertically. And I do this. So I very quickly build a wall. And this way I could build other things. We have a little example class implemented. So I could say The exemplar is just a class that groups different scripts we were working with at the lab, such as a Mandelbrot set representative in Minecraft, or many other fractals. So I could generate the exemplar. I went a little Mandelbrot set of size 50, which will be 50 blocks across and 50 blocks up. Tell it I want to start. At an X position of Y position. Here we flip the axis so we can use the point class in Squeak. There's the ground level and sun going, and there's the Mandelbrot set. Generating, I will go into creative mode so you can see what's happening. So while we look at this very pretty display, I'd like to talk about what's left to do in this project. As you can see, it's in a very early stage. There are still lots of things to implement. For example, we would like to make consults to Minecraft and to get results back, but our current architecture holds us back because what we're trying to do is to get a response from the server. Now, this is an asynchronous process, and if we want to expose the code to people who do not know nothing about programming, we don't want to get them straight into asynchronous processes. They would yell at us and be really scared. Also, it is not complete at all. We haven't talked about entities or any other Minecraft objects. For example, I would want to generate lots of sheep there walking around because maybe I would want to grind wool, and that is not implemented yet. And as you can see, it's really slow because we're using sockets. So we have come up with some alternatives to this. For example, we have thought about implementing a smalltalk virtual machine that runs on top of Java. So then our asynchronous processes will become synchronous since we would call primitives, and everything would be much easier also on the syntactic point of view. So this is a little demonstration. I hope you enjoy the shot. It was really short, but this is what I have to show now. Thank you.
I've never played Minecraft, so I spent some time inside Cerrato, and I like it for very similar reasons. Second Life, there is a scripting language with which people can script the objects that they create. I don't know if there is any particular wondering.
There are similar things. Currently, there's an implementation within Minecraft servers. There's something called a script block, but it's useful for when you are running a Minecraft server with lots of players. So you want to script some behaviors, like you want all of the players that logged on the game to spawn on a certain point and not be able to go beyond anything. There's also something called redstone, which is very particular kind of block within Minecraft that allows you to build some complex logic gates, but there is nothing on a really complex scripting level. You can't really do anything very complex without building huge structures.
Okay, I was about combining these with key toys or Scratch, because many for kids being able to use Scratch blocks or key toys interface would be great, because the develop education and then also program and change how they
Yes, we have thought about it, and I agree it would be very good. Since this is built on top of Squeak, each integration would be really easy, the same with Scratch, and it would be more suitable for younger ages, since they wouldn't have to be exposed to Smalltalk directly, but to script tiles. So yeah, we agree on that.
Do you have more practice throws?
Yes, in fact I do. Here's a cute Wonderboard set, but we also have a dragon cube implemented and a Cerrato triangle. What do you want to see? Choose. Fight. Sorry? Will do. Let's say 10 because here the size means the number of iterations on the algorithm. Diamond. Minus 97 minus 1. Oops. I didn't type one. Of size, starting for iterations. Size, sorry. 3. There we go. So here it is. It will run over the Wonderboard set, I think, or it won't. It won't. So we have some funny algorithms implemented.
You dominate the tool, you dominate the power. We'll see.
So, I mean, now I see like maybe it's in another stage that you have like environment, Java, Java server. But why did you choose the Java server? Like, there are alternatives.
Actually, we are not currently running on top of the server. We are modifying the client directly. So we are tweaking.
The Java we saw, that was the client.
That's actually Minecraft code. Yes, we decompiled Minecraft, deobfuscated the code, and tried to build on top of that. Yeah, I wouldn't have chosen Java.
Okay, last one.
I'm sorry, I didn't catch that. Yes, I have seen Brad Victor's blog regarding Minecraft on the Raspberry Pi. He did something really similar, but he used an open API that is available for the Minecraft Raspberry Pi version. The client version for PCs and for other consoles doesn't have an open API which you can use to make your own mods. There has been some discussion about it inside the Minecraft developers, but there hasn't nothing has come forward. So I am aware of some other people doing it, but we couldn't use that on this project, sadly. It would have made things easier.
Thank you.
Thanks to you. Thank you.